So microservices is a service-oriented architecture pattern where the applications are actually built as a collection of various smallest independent service units. And this is a software engineering approach which focuses on decomposing an application into a single function modules with well-defined interfaces, in which we saw the example, if you remember, the user authentication features and how we have different authentication microservices in the whole system. We do saw, we also saw this photo printing system for mobile devices, this example, and how the microservices architecture for this photo printing system looks like, and what are the different microservices associated in that photo printing system. So we just went over all those details about the microservices architecture. Then we're going to start here, microservice data design. So whenever you are designing the microservices architecture of a given system, you should always separate or isolate your data within that system service. So there should be very less amount of data sharing is allowed there. And actually, if sharing is unavoidable in certain circumstances or certain situations, you should design the microservices so that most sharing is only read only, and with a very minimal number of services responsible for data updates. So anyone who is going to just access that portion of the data which is available, that should be only read only, not editable. Then there is a concept of inconsistency management, which is related to the acid property of your database management system. ACID stands for atomicity, consistency, isolation, and duplication. So the database, in order to have a good database, or have a proper consistent database, all these properties and the acid properties, that is atomicity, consistency, isolation, and duplication, they should be properly handled. And a database is always consistent because in the event of some kind of failure, there are no partial updates of that data, and you need this for some kinds of system. So for example, if you move money from one account in a bank account, you move the money from one account A to account B within the same bank, it would be unacceptable for the account A to be debited without crediting the same amount to the account B. So there should be some sort of consistency in the throughout the transaction, uh, because this type of data are very user security sensitive. Okay. So when you use a microservices architecture, this kind of example that I gave you, the transaction in between different accounts. So this type of transaction is difficult to implement efficiently unless you can confine your data involved in the transaction into a single microservice. Okay. So it almost certainly means that you have to break the rule of microservice having a single responsibility. Consequently, if you are implementing a system such as banking system, where absolute data consistency is a critical requirement, you should normally use a shared database architecture. So the microservices architecture, like the database system, do have to obey the ACID transaction properties to certain extent. In that, there are two different types of data inconsistency management: the dependent data inconsistency and replica data inconsistency. So systems which will use the microservices, they have to be designed to tolerate some degrees of data inconsistency. You cannot have a totally proper consistent database, right? It's not possible. So the database used by different services or service replicas need to be completely consistent all of the time. So you need a means to ensure that the common data are eventually made consistent. In the dependent data inconsistency, the actions or the failures of one service can cause the data managed by another service to become inconsistent. And in your replica inconsistency, there are several replicas of the same service or microservice that are executing concurrently, and those microservices can have their own database copy, and each updates in its own copy of the service data. So these are some of the concepts associated with inconsistency management. There is another one situation, eventual consistency, where the system um, will just give a state of the database where the data may become consistent eventually. And you can how can you ensure this in that transaction? You can implement the eventual consistency by maintaining a transaction log. There is a figure in the next slide um, which will explain this. So when a database change will be made, so that will be recorded in a log or a file structure on a pending updates file structure. So other services instances will look at that log and update their own database and indicate that there has been some sort of change. So here is the pending transaction log. There is a service A1 which is using the database A, and also service A2 which is using the database A. So both of them using a shared database structure, the two different services. So when a database change is made, it is recorded in a pending transaction log here. So where all the database updates for every service will be tracked properly. So whenever other services instances look at this log, they will update their own database and indicate that they have made that change. So this gives the another meaning to the inconsistency management to certain extent. It is helpful for the eventual inconsistency. Next is service coordination. So actually, what is this? Whenever you have a certain type of process, it can be signified as a user session. So that user session may involve a series of processes, okay, or interactions, and those processes or operations have to be carried out in a specific order, which is also called workflow. There is the example that I was just showing you initially, the user ID authentication. So in the authentication workflow, here this figure, it's showing the authentication workflow actually, which is comparable to the user ID authentication mechanism that we saw initially in the microservices architecture example. You can relate this to that structure. So here this workflow, authentication workflow for the user ID or password authentication, basically shows the steps involved in authenticating an user. So actually what is happening here, if you look thoroughly, it's pretty easy. Just this is the starting point, this is the ending point. There are two ending points in terms of sequential successful attempt to get a sense of something like the authentication is done properly, and in case of certain type of failure, what may happen. And these are all the processes. These diamond signs are for the decision signs. Okay, so when you are starting here for the first attempt, if the authorization is, you are checking whether the authorization is failing or not, and you are tracking it through the login, and thus checking the login whether it is invalid or okay. So what are the different conditions again and different processes in the workflow if the login is correct or login is invalid? So here this example is basically showing the meaning of or the process of something like user is allowed um, 3 login attempts before the system indicates that the login has failed. So user has to at most make 3 login attempts. After that, you know, it will just give an error message that the whole login authentication mechanism has totally failed, but there should be 3 attempts. So within those 3 attempts, what are the actual orders in the workflow for the services? That's what is actually explaining about. So to get more details about it, I'll suggest you to read the book properly and see the explanation thoroughly. And what are the different workflow directions here in the basis of the user identity authentication mechanism. So one way to implement the workflow is to define the workflow explicitly and to have a separate service that executes the workflow by calling the component services in turn. So there is a concept called orchestration, which reflects the meaning or a notion that that an orchestra conductor instructs the musicians when to play their parts. So in an orchestrated system, in the next figure here in the service orchestration, in the orchestrated system there is an overall controller, authentication controller is there. So here in the service orchestration, the authentication controller is there, uh, and this controller actually handles all the communication between the microservices, login service, password service, or if there are any other services as well, and it directs each service to perform the intended function as they are supposed to do. And one of the disadvantage of this type of mechanism, orchestration mechanism, is that the controller needs to directly communicate with each service and wait for each service's response as well. Okay. And then here there is an alternative approach, which is service choreography. Um, so it is also often recommended for the microservices where there is no conductor for the workflow like your orchestration. And the choreography depends on each service emitting an event to indicate that it has completed the processing. Okay, so actually what happens here, the main problem in the service choreography is that there is no simple correspondence between the workflow and the actual processing that takes place. And this makes this type of workflow harder to debug. But if there is some issue, to go back again and fix it, it is really difficult in this scenario. And in your orchestrated approach, if a service fails, the controller knows which service has failed and where the failure has occurred in overall process. Okay, so that's the difference in between the mechanism of the service orchestration and choreography. Uh, so what type of different failures possible in the microservices system? So large scale systems are more prone to failures, and if there are thousands of service instances in a cloud based system, failures are inevitable to occur, right? And there could be three different types of failures: internal, external, and performance failure. So internal failure is a condition that are detected by the service and can be reported to the service requester in an error message. So one type of example of this type of failure where it takes an URL as an input and discovers that this is an invalid link. So sometimes you use some type of web address that is your URL or uniform resource locator. It's sort of like www.google.com, right? So suppose you look for that URL and due to some reason maybe that link won't work and it will give you that the failure like the link is an invalid link. That is an internal service type of failure. External service failure. Um, this type of failure have an external cause that affects the availability of the service, and the failure may cause the service to become unresponsive, and actions may be taken to restart of the service. And your service performance failure, it degrades to an unacceptable level, and this may be due to a heavy load or an internal problem with the service. And external service monitoring can be used to detect performance failures and unresponsive services. Uh, so actually, to report the a typical type of microservice failure is to use the HTTP, hypertext transfer protocol. Okay, so is to use this type of status code. You may have seen this in some of the URLs, okay, in most of the URLs. So this type of protocol is used, which is a status code, and it indicates whether or not a request has succeeded, and service response the service responses should actually include a status that reflects the success or otherwise the service request. So there is a status code. Sometimes you may have seen this type of status code, 200. That means you may not see that, but this type of status code, it means that the service has completed its processing successfully. Okay, that means the request has been successful, the request that is made to the web. And there are other status codes such as 300 or 500. So they indicate that there is some sort of failure. So you may have seen this type of or received this type of status code while trying to access the blackboard at certain time. So whenever something is success, that means this type of status code is returned. There are different status codes for different types of mechanisms with the web or the internet. Mm, then comes timeouts and circuit breakers. So as we are learning about different failures, so the timeout or the circuit breakers comes into picture. Uh, So one way to discover whether a service that you are requesting is unavailable or running slowly is to put a timeout on the request. So timeout is a kind of a counter that is associated with the service request and starts running when the request is made. So there should be some sort of predefined value. So once the counter reaches that predefined value, a certain amount of time, okay, that should be predefined or previously defined. So the calling service will assume that the service request has failed and acts accordingly. So when it reaches that predefined timeout duration. Here is a structure showing an example for the communication or request between two different services S1 and S2, how a circuit breaker looks like, what a circuit breaker looks like, where service S1 makes a request to service S2 instead of calling the service directly, and the service call is routed through a circuit breaker, which again has different compartments. So a circuit breaker includes a service timeout mechanism that starts when the service S1 sends a request to service S2, and if the S2 responds quickly, then the response is returned to the calling service S1. But if, let's say, the service S2 doesn't respond after several tries, okay, and that depends upon how many number of tries has been set out. And but there the circuit breaker will assume that the S2 has failed, and it blows. So that number of, how many number of times or the retries should be there, so that should be properly set up inside the circuit breaker. So if, let's say, there are number of tries are 3, so each time 3 different times there will be the workflow, and will also check that whether the service that is made from the S1 to S2, whether the S2 is available or not, that is responsible or responsive or not. So after it will when it will reach the maximum number of tries, then it will decide that there is some type of failure. Okay, and it means that when a failure call is made to the service that is timing out, the circuit breaker responds with a failure status code, the 300 500 that I mentioned previously. And here the requesting service, that is S1, doesn't have to wait for the requested service S2 to time out before detecting a problem. That is your timeout and circuit breaker. Next, we are going to learn about some of the new terms. It's also related to how the service requests are being made. So RESTful services. Microservices may communicate synchronously or asynchronously. We saw those two approaches previously as well. So there are different protocols for message organization and communication. And one of the approach for service integration is your RESTful protocol, that is representational state transfer protocol. So this type of architectural style is based on the idea of transferring the representations of digital sources from a client. So you can think of a resource such as a chunk of data, such as credit card details, a person's medical record, a library catalog, like that. And resources are accessed through their own URI. Okay, what is URI? We will look into that. URI and RESTful services to operate on these resources. So your RESTful service is a basic approach used in the web, where the resource is a page to be displayed in the user's browser. So there is an HTML representation which is generated by the service server in response to um, a, an HTTP request. There is a GET request which will be discussed later on, and that HTTP request will be transferred to the client for display by a browser or a special purpose application. Here are some of the principles in this slide for the RESTful service. Different HTTP verbs such as get, put, post, delete, then stateless service, URI, and XML JSON. So we will look into more details about it in the next slides coming. The slides those will be coming up. The get, put, post, delete. Let's look into the stateless service. So statelessness means that every HTTP request happens in complete isolation. So whenever a client makes a request, HTTP request, it includes all the information necessary for the server to fulfill the request. And the server actually processes the requests based only on information relayed or transmitted with each request, and doesn't rely on the information from earlier requests. It means that the server doesn't need to hold onto the state information between requests. Okay, and different requests can be processed by different servers, but at a certain point of time, just the alternative, the reverse of the concept is your stateful services, which will have where the stateful services will have either a database or a based on an internet protocol that will have the understanding or the all the states handling on that single host or the server. It needs all the details in the stateful services, but in the stateless services it doesn't rely on the information from all the previous requests. Then comes your URI. So URI, web service, the uniform resource identifier, it is a generic term for the name of all resources connected to the World Wide Web, and URIs enable the protocols over the internet to conduct the interaction between and among the different resources. Then using the XML or JSON, this is another type of principle. So JSON stands for JavaScript Object Notation. So it's an open standard file format that is used for browser server communication. It's a language independent data format, and XML stands for your extensible markup language, and it's a set of rules that help users encode the documents in a human readable format and machine readable as well. Actually, there are so many terms. It's they're all if you are going to at some point of time in future, you will get familiar to the computer networking course. Okay. uh, then in that course all these concepts will be discussed more thoroughly. How in the computer networking concept different protocols are there, how those protocols are stacked together, and how different requests are being made, it will be more clearer to you. So now let's look into the HTTP verb. So we are going to emphasize on the get, put, post, delete terms here, which are associated with the different RESTful service operations such as create, read, update, and delete. So you can refer to this slide for the details of these. Let's look into one example to better understand it. Here, your create is actually associated with creating a resource with a given URI. Then reading means reading some data of that, reading specifically the information about the service or the data. Then update, uh, and your create is actually associated with the post term, read is associated with the get term, update is associated with the put term, which is responsible for updating some type of data or information in that request, and delete is used using the delete term to delete something from the request. So in this example here, this example is actually taken from a link. Let me provide you that in the chat window. If you can also refer to that on your own. This is from a website, guru99.com. Um, it gives the example of a restful web service defined in the link that I just provided. And here client makes any request to this web server, and it is going to specify any of the normal HTTP verbs such as your get, post, put, or delete. Okay, and let's see what different types of functions are going to carried out here. So in the post, this is the resource for the employee or the client, and in the post you would be basically creating a new employee using the RESTful web service, this post term. The get here, it will be used to get a list of all the employee using the RESTful web service. The put, it was associated with the update. So it will be used to update all the employee using the web service. And delete, it's used to delete all the employee using the RESTful services if you need to delete anything. So if we want to take a look from a perspective of a single record, just a single record for a single employee. So let's say the employee number is 1, who's employee for a single resource. So there could be some sort of possible actions. And for the post, let's say post, what will be the meaning? So the post, it will not be applicable since we are just fetching the data of employee 1 which is already created. So post is associated with creation. We are not creating, the employee is already created, we just need the data about it, employee 1. Your get method, it could be used to get the details of the employee as it is a read operation, and it could be done using that RESTful web service. Your put, it could be used to update the details of the employee number 1 using that web service, RESTful web service. And deletion, this is also possible. You could delete the detail of employee with the employee number as 1. This is one example. In your book, you could find the example of this URL, trafficinfo.net incidents. You could refer to it. This is an example of properly understanding the RESTful service operations. Here in this example, in this link here particularly, it will have the information about what type of incident is there, if there is a traffic delay, road work, or different type of or maybe a certain type of accident is there. So user can give a request to the system to get the details about any type of such incident on the road if they are planning to travel. So there are some other information of this RESTful services. So actually here is the incident description for that RESTful service. So when implemented as a RESTful service, web service, you need to design the resource structure so that the incidents are organized hierarchically. Okay. For example, for our particular link that is provided here, in the link, this link here, I'm talking about this one, trafficinfo.net incidents. So here incidents may be recorded according to a road identifier. That could be your A90. This is a road identifier. The location, so for this location they have used a name as Stonehaven. You could read the details from the book. And for a particular direction, they are using north. So due to that, that is the ends letter, and the incident number is 1. So that's why you have N1, incident number 1. And due to that, it could be accessed using an URI, Uniform Resource Identifier, in this way. So this C is the first link where you will access these incidents. So now in which road, the road identifier, what location, what direction, and what incident number. This whole thing will give you the exact information. This is how the RESTful web service works. So accessing the URI returns the description of the incident, including the time reported, its status, whether it is significant, serious, or minor, and a narrative description like this is shown here in this table. Okay. If we try to compare it with our RESTful services, all the terms, how we could have all those details that is provided here in the service operations. So for retrieving, you use the get verb, which will have access to the reported incident or whatever is the incident, all the details. If you want to create or add a new information, you could use the post verb. If you want to update, you could use the put verb. If you want to delete, just use the delete verb. Same thing that we saw for the employee from Guru 99 example. Same way you could have this incident RESTful service architecture. Then an HTTP request, actually what happens in a RESTful microservices, they accept the HTTP request based on the RESTful style and process the requests and create the HTTP responses to them. Okay. So whatever is required based on the service request, accordingly your processing will be done. There are some more details into it. What does actually your the request, response, everything are in the XML JSON format. So what does the actual package look like? The detail is provided in the book. You could have access to those and read it thoroughly to understand how the description is actually found in the how does the XML, the body of the request or the response, how it includes the service parameters and how they are represented using the XML or the JSON, as shown in this table here, and your how a message body might be structured in XML or the JSON. Give me a second. Yeah, okay. Here is a request and response body for the example of our incident. Okay. If you compare it with this request response template, how the HTTP verb, URI, HTTP version will look like, and you can compare it with our particular example. What type of request get, then incident, then what is the number, road number, what is the location, what type of request, all those details are how they will be structured for the request and response that is given here. So that's all we have. Yeah, that's the endpoint. So here with this, we are going to get finished with our microservices architecture. I have already made announcement about the technology stack, which was due on 25th, the discussion board. There has been an activity diagram assignment, but the test 5 was not available to you. That is now available, which will include all the concepts about whatever concepts we have learned in this whole chapter. everything. Cloud services, microservices architecture, the UML designs, diagrams, everything. All the concepts will be included in the test. So please complete this test. Um, Now next, I'm going to get started with your chapter 6 or unit 6 prototyping. This is a short chapter actually. So in prototyping, uh, how we will learn how it is associated with your designing accept of the software. What are the different what is actually prototyping, what is storyboarding in terms of prototyping. Okay, all those concepts will be covered in this chapter. In addition to that, uh, there is a discussion, then PowerPoint review, assignment, test. Okay. So in addition to that, before the assignments or the homework, let's look into these two different links. So in the presentation that I'm going to explain to you, you will get a basic understanding of what is your storyboarding or prototyping, but more details about it, thorough details about it could be um, gained from this link here. The software engineering prototyping model. What are the different types of prototyping models? What goes in there? What are the concepts? What happens inside it? Advantages, disadvantages, everything are covered. And I have, please go through these two different links. Do understand the rapid prototyping. What is your rapid prototyping model? Evolutionary prototyping, various types of prototyping approaches. You need to have an understanding about it. Uh, okay, so let's review our homework later on. Let's get started with the concept first. What is your prototyping actually? So we know what is a design, right, for software. So one of the design techniques we could use is to create storyboard prototypes like a template. So storyboarding, here our emphasis will be on the storyboarding. So storyboarding is an iterative interaction design methodology. Um okay, here is the main points that we are going to cover in this content or presentation. So storyboarding is an iterative and interaction design methodology which uses a series of sketches, diagrams, or pictures to demonstrate an end-to-end solution for a user scenario. And this type of prototyping is used to illustrate the design concepts and obtain feedback early in the design state or design process. The storyboarding is useful for refining, validating the concepts before writing detailed functional specification. Okay, and this storyboarding, it helps us. It enables you to work effectively with your multidisciplinary team. Okay, there could be requirement. There could be managers, there could be developers, there could be testers. So there are multiple multidisciplinary team. Your team could have different type of people which have different type of expertise. So in that team, this storyboarding will help you to create highly usable, user-centered designs. So storyboarding is basically used in initial stages, and the main motive is to get a sense of how the user interface will look, feel, and behave, just the basic understanding. So it is sort of a graphic organizer which provides the viewer with a high level of project. So you know about agile software development methodology, right? In the agile approach, a storyboard can help developers quickly get a sense of what work still needs to be completed. And in our Scrum software development, the storyboard may be called as a task board. Okay. And here, both creative and technical professionals use this technique because it streamlines the design and the whole process, development process, and it's easier to make changes also in there. And it helps different people in the team to arrive at a same understanding and of what the product will actually currently do, how it will be structured, and how it will be laid out initially. Then to see how to begin, how to get started with storyboarding actually. So storyboarding don't actually contain the text and images, but simply offer a general sketch of the layout, functionality, and flow, etc. Okay, these are the basic steps what we are going to do in the storyboarding. So first, get started with a series of blank pages or rectangles in the page, and one for the each of the important feature or section of the user interface. Then try to fill in basic ideas and sections on for each of the screen, and try to include notes for them. Okay, and first try to get have multiple simple boxes, and then you could move into more complexity. You can also suggest wireframe diagrams initially. So wireframe diagrams are something which we are going to cover towards the end of this unit, and try not to get too polished or fancy in the early stages. So the storyboard diagram will actually show the screens that make up the user interface of a system and how to navigate between them. Okay, a system may functionally do exactly what a user desires, but if the path the user takes through the screens don't match up with the way they want to work, then it can be frustrating. Then it could lead to a frustrating experience for the user. Uh, there is a term, Lorem Ipsum. You just got an idea of how to get started with storyboarding, correct? We just thought about what will go into the whole system, and then got started with the blank page with having empty rectangles for important features, right? Now the next thing is that to fill up some dummy text in it, so that how much space each rectangle will take, that will be decided here. So Lorem Ipsum is actually a dummy text of printing and typesetting industry. Your Lorem Ipsum has been the industry standard dummy text since the 1500s. So when an unknown printer took a gallery of type and scrambled it to make a type of specimen book. There is more detail into it for the Lorem Ipsum. You can refer to this link here. I'm just going to open the lipsum.com. Here, this is a document about the evolution of the Lorem Ipsum. You can refer to it. These are the two different generators, lipsum.com and loremipsum.io. So Lorem Ipsum is a name for a common type of a placeholder text, also known as a filler or a dummy text. It is simply a text copy that serves to fill up a space without actually saying anything meaningful. There is nothing meaningful in there. It is essentially nonsense text that still gives an idea of what real words will look like in the final product. Here is an example of your Lorem Ipsum. Okay, some time of random dummy text will be added into certain rectangle for a certain feature. Uh, this Lorem Ipsum is used in website designing and development mostly, and Yeah, so that's the detail about it. You could refer to these links to have more details if you are more interested about the term lorem ipsum. Next comes wireframe diagrams. Here is one link for this diagram. Let me open that first. Oh, okay. Due to some reason it's not working. Let me see. Oh, it opened. Here is this link. Uh, this is what your wireframe diagram actually looks like. Okay, you don't have anything, but still it gives you certain idea about how your web page will actually look like. So originally the term wireframe meant a visual representation of your three-dimensional objects like those used in product design and development. And now it is used to describe 3D modeling, three-dimensional modeling for animation or development of 2D web pages or mobile applications. So this type of diagram is a grayscale visual representation of the structure and functionality of a single web page or a mobile application screen. They are used early in the development process to establish the basic structure of the page before the visual design and content is added. It can be created using paper, straight into HTML, CSS, or using software applications as well. Okay, there are different ways you can, it can be done in different ways. And the diagrams, the main advantage is that it can save you a lot of time and consequently the money, and it can help you to make changes faster, provides better knowledge of entire project, minimizing the possibility and additional redesigns. Here are some of the examples. There is a mobile app storyboard, two different links and a PowerPoint presentation is provided. So they will give you some sort of the ideas about a sample wireframe diagram and different tips. So last link is actually the PPT for the wireframe template. You can use this template to construct the wireframe diagram. These are some of the commonly used tools for the wireframe diagram. You could use PowerPoint, you could use Visio. There are other two different tools are there. Image editor, Adobe Photoshop could be used, or Vasalmic could be used as well. Here is the link to that tool. Then after your wireframe diagrams, um, the next thing, first you got the understanding of the basic architecture, the structure or the functional aspect. The next thing is that you could add branding, color, fonts, different graphics to provide give it a more fancier look or feel. So this is what goes into after the wireframes. So that's all about the storyboarding prototyping. This is the basic. Main thing is that you need to go through these links, look into examples, because there is an assignment regarding that. In the unit, you will find this discussion board prototyping about prototyping. So more details could be found through the useful links from here. Okay. And the videos. So based on those details, answer to the points or to the questions here in this discussion. There is a test. Then next is your individual storyboard assignment. Um, it's it actually an example about a mobile application interface. Here there is some explanation. The requirement for this assignment, read carefully. So what is actually needed in the presentation? You need to basically prepare a presentation. What are the things required and all those details. So there should be a main slide with name, all the details about you, the main screen, the viewing screen of the mobile application interface, create edit screen, course catalog filtering screen, and the additional screens. Okay. So after that, mm, you need to also use some sort of Lorem Ipsum text in your application. Okay. And your story board should use this point presentation, the template that I have provided. Yeah, here it is. Okay. So this is how it will look like. There are different presentation slides included. You need to fill up the storyboard. Use all the useful links that I have provided and how to develop your applications. What are the requirements actually? So here is an example where from diagram for the mobile application, the different examples or tips provided here. You could take the reference from all the links, and in this template, oh, where did that go? Okay, here it is. So you need to basically fill up this whole template as per the requirement here. What is asked here, how your main screen will look like, how your creator editing screen will look like. So following all the links that are provided, get a sense of how to do the storyboarding and complete the assignment. Does anyone have any questions so far? Okay, well, so if you couldn't think of anything right now, that's fine. If you have any, if you need any assistance, let me know. You can email me always. First, try to read. Uh, yeah, I'll post the lecture. This is being recorded, this session. I'll post the lecture.